Now, one important probability concept is conditional probability. In the conditional probability, where you have some additional information, you are given some additional information, and on behalf of that, you need to modify the probability. How means how your probability can incorporate the additional information. This is the conditional probability. So when you are computing the probability and some additional information is given, then on the basis of that information you have to incorporate into the probability. And if your probability is incorporating such additional information, then this it is known as actually the conditional probability. Sometimes you can say that there will be rain, probability for rain, given that it is cloudy. This is the information you are given. So you are going to compute probability for the rain, and we have the notion for denoting the conditional probability like this, and you have the cloudy. Weather is cloudy. So this is the information given to you. So what you are going to compute? What you are going to compute the probability for rain, means whether the rain will occurs or not. This event, rain will occur or not, and provided that this information is given, cloudy. So you are given that this is the notion of given. So this occurred, this event already occurred, this event has occurred. This event has occurred means the weather is cloudy. So somebody, you are sitting at the room and somebody says that, okay, what is the probability that it will be rain because the weather is cloudy? So if you know that weather is cloudy, then your probability will be different. If you don't know the weather is cloudy, then your probability will may be different. So this additional information is given, cloudy. On the basis of that, you need to compute the probability for the rain. And this probability must include this additional information. And this is the notion of the conditional probability. When your probability is going to include the additional information, so you are incorporating the additional information given to you in the probability, then this is the conditional probability. So this is very important. Most of the time you have to deal with the conditional probability. So before observing the outcome of a random experiment, you are given information regarding the outcome. So you have given some information. So how should this information be used in prediction of the outcome? So you have to include the additional information you are given. Means how probability be adjusted to take into account this information. You are dealing with such kind of situation. Or denoting the conditional probability, this is the notion. Yes. So A probability of, you can read like this, probability of A given B. So this is what? This means given. Given. You can also say that what is the probability of A given that event B has occurred. So event B has already occurred, you are given. So in this information, how you are going to modify your probability A. And this is equal to probability of A and B, probability of A intersection B divided by probability of B. And of course, since it is in the denominator, probability of B cannot be 0. This cannot be 0. Question is that how this comes? Why this? Why this? So see, as soon as you are telling that event B has occurred, okay, like you have the two events. You have the two events and A and B, and you are telling that you have the event A, you have the event B. Okay, you may have the like this situation. So in the sample space, you have the event A and B, and you are supposed to compute the probability for A given that B has occurred. So this is the sample space, and this event B has occurred. This event has occurred. This has occurred. Okay, event B has occurred. Now you are given the information this event B has occurred. So once event B has occurred, and you need to determine the probability for the event A is occur. So what is the probability for the event A? This will occur given that event B has occurred. Now see that as soon as you are told that event B has occurred, it means outcome, the result of experiment will belongs to this particular set. So your outcome of experiment will be in the set B, denoted by the set B. So you have performed the experiment, and your outcome will be in the set B. Because you say that B occurred, it means your outcome will be within this region. So anywhere within this B. So here you have the outcome. Okay, and you the when A will occur if and only if and only if whatever you have event which occurred in the set B, and that event must be here in the intersection, in this part of the intersection. So if event B occurs, then outcome can be here, or here. So event A will occur if and only if outcome will be at the intersection. So outcome, if your outcome is in the intersection, then you can say that event occurs. So you may have the any number of outcomes here, and the outcome occurs, but you don't know that whether outcome is here or here or here or here or here. So but you are only given that event B has occurred. So once B has occurred, and you need to determine the probability for A. So probability for A given B is occurred means the sample space is now reduces. Before that sample space was S, now the sample space becomes simply B. And within B, how many points, how many outcomes are there which are in the intersection? So this actually, how many points are there in the intersection? This will denote this divided by the total number of points in the set B, and this will be the probability for this. So you can say that simply like this. You have the number of points in the intersection A intersection B divided by total number of points. Total number of points means total number of outcomes. So probability of A given B can be computed like this: number of outcomes in the A intersection B divided by number of outcomes in the B. And see that number of outcomes in B divided by the total number of outcomes. Number of outcome in the event B divided by total number of outcomes. So this divided by this, and number of outcomes in B divided by total number of outcome. This is the probability of B, and this is simply the probability of A intersection B, because A intersection B divided by total number of it. So that's why it is written probability of A intersection B divided by total number of B. But you can compute like this. If you know that how many points are there, how many outcomes are there in the intersection, and then total number of outcomes in the set B, so you can compute the probability of conditional probability A given B. So that's why this formula comes. So probability of this can be written as probability of A intersection B divided by probability of B. Here probability of B is given because now this is the sample space now, and intersection can be what? Maximum can be what? This complete set you may include. So whole elements of B can be in the intersection. So this will be simply this simply is equal to the B, and probability of B divided by probability of B is equal to 1. And this is the condition, you know, that the sample space. So that's why this formula comes. Okay. So as soon you are told that event B has occurred, then the sample space from S is reduces to the sample space of B. This is important. So that's why you have to divide by the B. So if we are told that event B has occurred, what then the sample space is restricted to the region B. So this is the sample space now. This sample space. This is the new sample space. Earlier the sample space was this, but you are given the information that event occur. Event occur means your outcome will be within this set B. And for event A occurs, event A will occur if and only if your outcome is here. Your outcome is here. So that's why probability of A intersection B divided by probability of B. Means if you know the probability for A intersection and probability of B, then you can compute. Or if you know the number of elements in the intersection and total number of elements in the event B, then you can also be able to compute the probability of A given B. So the probability within B has to be normalized, and this is achieved by dividing by B. So you are dividing by the probability of B, because you may have the number of points here, and for normalization you are going to probability for this region is B, and you are going to divide. So whenever you come to know that some event has occurred, then the sample space is going to modify, and you need to remember that what is the new sample space. So earlier the sample space was this, and now the sample space becomes this. So by getting the additional information, actually you can say that probability for the information is probability for occurring the other event you are going to compute. So both events A and B are, remember that event A and B occurred at the same time. This is important. Okay, what means B has occurred, and for A will also occur. For that you are deriving the probability. So if your outcome is here, then actually what happened? If your outcome is here, then event B occurred and also event A occurred. In a given university, the probability that a specific professor is doing research is 80%. The probability that his student is doing research is 65%. And while the probability that they both doing research is 60%. So you have in some university, some specific, it is talked about some specific professor, and that professor is doing research. The probability for doing research of such professor is 80%, means 0.8 you can say, and the probability that his students doing research is 65%. So you can denote the probability. This is the student. You can say that student you can refer by denoting A. Professor can be denoted by the event B. Okay. So B denotes the event that professor is doing research. So what is the probability that professor is doing research? Probability of B. It is given that 80% means 0.8. 0.80. The probability that his students doing research. So event A denotes the probability of the students is doing research. So A denotes the probability for the students doing researches. So what is the probability for A? So probability for A is 0.65. While the probability that they both doing research is 60%. So here you have probability of A intersection B is what? 0.6. They both are doing research means intersection. If the professor is doing research, yeah, this is the conditional probability. This is the information you are given. If the professor is doing research, then what is the probability that his students is also doing research? We need to determine the probability that his students is doing research. Means you are going to compute probability for A means student. Student is going to do research given that professor is doing research. So professor means B. We need to compute this thing. So we are going to compute that probability of A given B, and B means professor. It is given that the professor is doing research. If professor is doing research, means this event has occurred. Professor is doing research. And what is the probability that student is doing research? Then simply you know the formula. So this is equal to probability of A and B divided by probability of B. So probability of A intersection B means both are doing the research is 0.6, and probability for the B is 0.8. So you have the, and this comes actually, uh, this means 3 and 3 by 4. So this is 3 by 4 means 0.75. So this is the probability that students is doing the research is 0.75. So this is the notion of the conditional probability. So you, this probability, what is the probability that students is doing research? 65%. But you are given some additional information, and on behalf of the additional information, your probability improves. Your probability is going to incorporate the additional information. So this kind of notion is there. This is the answer. And this is the same is given here. So let B is the event that professor is doing research, and always you have to write in, whenever you have some problem, you just denote the event by some letters, not necessarily A and B, you can also denote by X and Y, and you can also denote the professor by writing T and students by writing S, whatever you can feel. Read the questions carefully and denote the events, and you know that what you see, that what are the given, what information is given, and what you need to compute. That's all. So you are supposed to compute that what is the probability that students is doing research given that professor is doing research. So we know the notion of the, since you have the directly you have the probability given intersection of probability of B, then you can directly use this this formula. If you are given the number of elements in intersection, total number of elements in B, then you can simply use the probability concept. Cardinality, you can see the how many elements are here and how many elements are here. Just divide. So if you are given the probability for the intersection, then it's okay. It becomes very simple. So this is the case. So actually, what you are going to do actually, you are at here. You have the probability B has occurred, and now you are going to compute the probability for the A. You are going to compute the probability for A, given that probability B. Probability means event has already occurred, means probability for B. You are here, and now you are going to compute for the A, given that this, because you are here means this already occurred. So this is actually notion of PA B, and this is equal to what? This is equal to probability of A intersection B. So probability of A intersection B is equal to probability of A given B multiplied by this. You can solve this exercise. What this says, you are rolling a fair die, means we have the equally likely probability that die means 6 faces, you know, 1 2 3 4 5 6 will occur. So we roll a fair die. Let A be the event. A is the event that the outcome is an odd number. Outcome is an odd number. So 1 2 3 5, odd number is this only. Okay. Also let B be the event that outcome is less than or equal to 3. Less than or equal to 3. So B denotes the event that outcome is less than or equal to 3. So less than or equal to 3 means 1 2 3. So you have the sample space actually. You have the sample space like this. So this is the sample space. In this sample space, we have the two events. This is event A. You can say this is event B. Say this is A. This is B. So A is what? 1 3 5. So here you have the 5. Say this is 1 and this is 3. Now event B. So event A is 1, 2, 5, 1, 3, 5. Event B 1, 2, 3. So this is 2 here. 1, 2, 3. Right? And you are rolling a die. And the sample space, you have the sample space as, and outside of these A and B union, you have 1, 2, 1, 2, 3. Somewhere will be 4, then 5 and 6. 4, 6 are outside the A and B. No issue. Now say, you are rolling a die and there are two events. One is A and one is B. What is the probability that, what is the probability of A? What is the probability of A? So what is the probability of A? How you can compute? So probability of A is equal to what? Number of outcome in A. How many outcomes are there? 3 divided by, so this is 1 by 2. So this answer we are getting. Now second question, what is the probability, what is the probability of A given B? So you need to compute probability of A given B. Now the information is given that B has occurred. Now event A will occur if and only if the outcome will be here. So because in the A, in the A you have the 1, and in the intersection you will also have the 1, and here you have the 3, here you also have the 3. So either 1 or 3, means either 1 or 3. If outcome is 1, then also A occurred. If outcome is 3, then also A occurred. If outcome is B 2, then A will not occur. We are going to determine the probability of A given that B has occurred. B has occurred. It means B has occurred. This means B can be 1, 2 or 3. Now B occurred means any one of the outcome. Your outcome belongs to B. So your outcome is either A 1 or you 2 or 3. So A will occur if and only if outcome will be either 1 or outcome can be 3. So once you are telling that B has occurred, means this becomes the sample space. And in this sample space, you have the 3 points, and out of the 3 points, there are 2 points in the intersection. So probability for A and B is actually cardinality of A intersection B, okay, divided by cardinality of this. So number of element in this is what? The number of element in the intersection is 2, and number of element in the total number of element in the event B is what? 3. So 2 by 3. So this is the, so probability, this is the probability now. So probability for A given B is now 2 by 3. Now there are examples for the conditional probability. Conditional probability is also the probability. So whatever examples you can find in the probability, you can also find in the conditional probability. So we have already known that if you have the probability theory, then probability of A, exam says that probability of A is greater than or equal to 0. Now this can be modified by this, since you are given the additional information. So for any event A, you can say that probability of A given B is greater than or equal to 0. Since conditional probability is also a probability, then probability must be greater than or equal to 0. It cannot be negative. When it will be equal to 1? When actually A is equal to B. When A is equal to B. Means this, you have the B, this is the B, and this is the A. This is the A. Okay. And if in the intersection, if intersection is equal to the B, means complete, you have the notion like this actually. You can say this can be So this is A and this is B. If this is B and B has occurred, the intersection of B, A and B is what? Complete B. So here number of element in the intersection is same as the number of element in B. So this is the case of probability of B given B. This is 1. So intersection is the same, becomes B. So A intersection B becomes the B. So that's why probability is 1. Means probability, since B is the new sample space now, so like we have seen in earlier that in the probability exams that probability of the sample space is 1. So this is the probability of the sample space. Probability of the sample space B, because this is the new sample space, given the B is 1. Exam 3. If A1, A2, A3 are the disjoint sets. Disjoint sets means there are no elements in common. Then probability of A1 union A2 union A3 given B is the probability of A1 given B plus probability of A2 given B plus probability of A3 given B. Simply, probability of A complement in the probability exam. What is this? 1 minus probability of A. Probability of A complement is 1 minus probability of A. And here, in case of the conditional probability, you are telling that probability of A complement given B is equal to 1 minus probability of A given B. Now if you have the three events A, B and C, so if you have the three events A, B and C, and assuming that probability of C is greater than 0, then there are some rules you can need to know. Here C denotes the complement, small c denotes the complement. AC means complement. Actually, you need to write as this. Okay, so this is the AC means A complement. So A complement given C is equal to 1 minus, we have come to know that probability of A given C. So this happen A complement C. We have seen earlier already. So here instead of B you have the C. That's all. So A given C. Now probability of empty set given C, always 0 because empty set has no outcome. So this is always 0. Even conditional probability is also 0. Probability of empty set given C is equal to 0. Now probability of A given C is the events. C is the event. Here this is the, you can cut it here, and this means A complement. Okay. Now probability of A given C is less than or equal to 1. We know that since this is the probability, then it can be maximum 1. No issue. Probability of A minus B given C. This is probability of A given C minus probability of A and B given C. This you have to. So probability of A minus B. Sure, you have the A and you have this is the B, and this is the, say for example, A. So probability of A minus B. So if you say the probability of A minus B, if you minus B, then you are interested in this region only. A minus B. So this is A minus B. So here you have the A. This is A minus B. Now probability of A minus B given C is the probability of A given C minus probability of A intersection B. Probability of A intersection B, you have to minus and given C, just like in the formula. And this is also important. Probability of A union B given C, simply probability of A given C plus probability of B given C minus probability of A intersection B given C. You have seen earlier in the OR operations A or B. So A or B is what? Probability of A. Probability of A or B means probability of A plus probability of B minus probability of A intersection B. But here you have to incorporate the given C. So probability of A, instead probability of A, you can say probability of A given C, probability of B given C, probability of A intersection B given C. So probability of A intersection B given C. The same thing is there, but only you have to incorporate the additional information. If A is subset of B, then probability of A given C, probability of A given C is less than or equal to probability of B given C. Yes, because A is the subset of B, so it can happen. Okay, so this happens. So these are the rules you need to remember. If A is the subset of B, then this is the bigger set B. So probability of B given C can be more than the probability of A given C. Event A intersection B will occur if and only if your item, this is the set A, this is the set A, and this is the set B, right? And this is the set C. And what is the intersection in this case? This is the intersection. This is the intersection. Somebody says you that outcome C occurred, means your out, means event C occurred. It means outcome can be here, 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 anywhere. But what is your interest? A intersection B, probability of A intersection B. This event will occur if and only if outcome will be here. Outcome will be here. So you have to compute the number of points here. You can see the number. You can find the number of. So if you find the number of points here, what number of points? A intersection B intersection C, or you just find the probability of this divided by the probability of C. So this can be equal to the probability of A intersection B, A intersection B intersection C means this, or A intersection B intersection C, like cardinality, divided by the number of elements in C. This is the chain rule of chain rule for conditional probability. This is a chain rule. So, okay, what it says, intersection, for the case of the intersection. So A1 intersection A2 intersection AN. If you want to compute this, and this is the conditional probability or the conditional probability, then what you have? Probability of A1, then probability of A2 given A1, then probability of A3 given A2 A1, means probability of AN given AN minus 1, AN minus 2 up to A1. Of course, this is the chain rule. This means you are here and you are going like this. So, and you are here. So here once you are here, you can say that this is the probability of A1 occurred. A1. Now again, after this, you say that A2 also occurred. A1 occurred, and A2 also occurred. Then you are going to say like this. Means you are going to. So this is the probability of A2. And before that, A1 already occurred. A1 occurred. Now you can go like this. Again, here you are having the probability for the A3. Probability for A3 given 2 already occurred. A2 occurred and A1 occurred. So A2 is occurred and A1 occurred. Then you are here, then probability of A4 you are going to compute. And once you are here, then three events occurred. Which one? A3 occurred, A2 occurred, and A1 occurred. This. From here, in this way, if you are here, and you can say that this is the last event. So this is the nth one. So this is the an. So probability of an given an minus 1. Before that you have the an minus 1 up to 1. This is the chain rule actually. So you are going to compute. So this is equal to what? This is actually probability of a1 and a2 and a3 and an. This is. So this multiply by this, multiply by this, multiply by this, multiply by this is equal to probability of a1 and a2 and a3 and an. So this is the chain rule. As you go in the depth of the tree, then you will see if you are here. Say a4. So probability of a4, you are here. So you have to incorporate the information that a2, a1 already occurred. a2 and a1 already occurred. Since this is the conditional probability, so you have to incorporate. So on the basis of that, you can compute the probability for a4 like this. If you are at this point, if you want to compute the probability for an, then you have to come to know that the event an minus 1, an minus 2 up to a1 have already occurred. And on the basis of this information you are computing, and then you know that multiplication, because you conditional probability, you know that a given b is equal to probability of a intersection b divided by probability of b, or you can say, so this is the probability of a intersection b is equal to probability of a given b multiplied by probability of b. So this is the probability of b simply, and this is the probability of a given b. Here you have the a and the b. So and you are going to multiply. So this is the multiplication, and whatever the multiplication, this is equal to probability of a and b. But remember that probability of a given b and probability of b given a, both are different. Are you getting me? Probability of a given b and probability of b given a is both are different. So probability of a given b is what? Probability of a intersection b divided by probability of b. Here probability of a intersection b divided by probability of a. This is. So sample space is changed. If you are saying that b occurred, then sample space is b. If you say that a occurred, then sample space is this. Sample space is going to change, and once sample space is going to change, you have the probability is different. For solving the probability questions, you have to read the question and again, then you come to know. So in a factory, there are 100 units. There are 100 units of certain product. Okay. So you have the 100 units. 5 of which are defective. We pick up 3 units from the 100 units at random. What is the probability that none of them are defective? You have the, say for example, you have the O1, O2, O3, O4, ON means so you can say that 100. So you have the 100 units. Okay, you have the 100 units, 5 of which are defective. So out of 100, 5 are defective. Means 5 are defective. So The unit which are not defective are 95. So what is the probability that none of them are what you are going to? We pick 3 units. You are picking unit A1 and A2 and A3. A1, A2, A3 can be anyone. You may pick up O1, then you can go for the O4 or you can go pick up O100. So randomly you are going to pick this. So assuming that you are going to pick up A1, A2 and A3. So we have pick up A1. What is the probability that we have pick up 3 units so that they are not defective? So what is the probability that A1 is not defective? Probability of A1. A1 is the event that it is not defective. A2 is the event that this unit is not defective. A3 is also the event that A3 is not defective. So you have picked. So what is the probability that A1 is not defective? At the beginning, out of 100, you are picking 1 unit, A1. So for what is the probability that this will be not defective? It will not be defective. What out of 100, 5 are defective. So not defective means how many not defective pieces? 95. And how many total pieces? 100. Why it is why it is conditional? Because you have pick up one. Now you are going to pick up second. So once you are going to pick up A2, what is the probability that this is not defective? You have pick up one means you are now reduced by one. Now you have the total number of units becomes 99. So here you have the 99. And how many total units which are not defective? 94 now, because one you have already picked up. So probability for the not defective in A2, because A1 has occurred, you have picked up. Now probability for A3. A3 is what? Probability for A3 is now 94, means you have now 93 units which are not defective, because okay, and two already you have picked up. So how much? Remember, 98. What is the probability that none of them are defective? Actually, what you are going to compute? Probability of A1 and A2 and A3. So probability of A1 and A2, probability of, so A1 is the unit which is not defective, A2 is the event which is not defective unit. So 3 units you have picked up, A1, A2, A3, and now you have come to know that. So what is this? This is equal to what? Probability of A1 multiplied by probability of A2 multiplied by probability of A3. So now you have A2. You have considered A2 because it becomes, you know that A1 has occurred. So that's why you have this information you have incorporated. Otherwise, instead of 99, it will be 195 again. So you have incorporated the information. That's what A2 and A3. So once you have A3, then you come to know. So simply it is the multiplication now. 95 upon 100, 94 upon 100, sorry, 99. Then you have 93 divided by 98. 0.8559. 0.855. So you can write like this in the 3 decimal. This is equivalent to 0.8, 5 and 6, because this is 9. So you can say like this. Okay, and which is the answer. So this is the way you have incorporated actually. So this will become this is the way you are going to use the chain rule. So whenever you are going to use the chain rules, you have to remember that if this is the ith probability, you are going to compute the probability of ith, then you need to know that you have computed already ith minus 1, a ith minus 2, and a in this way up to A1, like this. Okay, one more important concept is that independent. Two events are independent. How you can say that those two events are independent? So these events are not independent because you know that if you say that probability of A2 given A1, this affects. So in case of independent is that you can say that the information, whatever information you are going to give, it is not going to affect the probability. You are tossing a coin and head and tail will come. So if you are tossing a coin and first head may come, if you are here and again you are going to toss a coin, so it is not going to depend on the previous outcome. Even somebody may tell you that in the first toss head came. So when the information is not supporting you, it means uh, it means you have the events are the independent. So knowing that the previous event occurred, it is not going to affect in the probability. So that's why even you are not going to say that probability of A and B is simply the multiplication of that. So simply you are having the probability you are here and you are here. Probability that head will come is 1 by 2. Probability that again head will come is here you have the 1 by 2. And hence probability that in the two tasks head will appear is what? 1 by 2 into 1 by 2 is equal to 1 by 4. This is. So this is not going to affect. Every time you toss, the chances for head is 50%, chances for tail is 50%. It is not affecting the previous outcome. So that's why simply if two events A and B are independent, then probability of A and B is equal to probability of A times probability of B. So here, if A and B are independent, then you can say that probability of A given B is equal to probability of A. If the events are independent, then it is not going to affect this information. So whatever be the probability of A is the remains same as the probability of A given B in case of the independent, right? So okay, probability of B, probability of A is not zero, then probability of A given B, you know that by the conditional probability, A intersection B divided by B, and this is equal to what? Probability of A into probability of B. Why it is so? Because probability of in case of the events which are independent, probability of A and B is probability of A and probability of B. So B and B cancel. This is probability of A. So probability of A is equal to probability of A given B. Probability of A given B is equal to probability of A. Yes. It is not going to change. Here also probability of B given A is same as probability of B. So probability of B given A, probability of A intersection B divided by probability of A. Probability of A and B, since this is the independent, it is probability of A and probability of B, simply multiplication. And then this is in case of independence, the conditional probability of an event is not affected by the knowledge of the other event. This is mutually exclusive events are highly dependent on the other. Okay, in case of mutually exclusive, this is happens always. Probability of A and 0, probability of B is 0. Then we say that okay, events are independent. In all other cases, the events are not independent. So okay, this is we know that. So mutually exclusive, we know that A and B cannot occur simultaneously. This is one thing. If one event occurs, then other event does not occur. If they are the mutually exclusive. Independent event. Probability of A and B. This is the probability of A multiplied by probability of B. simply multiplication. Probability of A and B divided by probability of B. And this is what probability of A and B is equal to probability of A and B. You can also write like this. Why it is so? Probability of A and B divided by probability of, because probability of A and B, probability of A and probability of B, and B cancel, P2 cancel PA. Probability of PA. And probability of PA means, you can also write like this, probability of A divided by probability of S. Probability of S is always 1. It means probability of, this is 1, confirm probability. So you can also say like this. The ratio of the probability of the set A within B is the same as the ratio of the probability of the set A within the entire sample space. So simply you mean that if A and B are independent, then knowing that other has occurred is not going to change the probability of some other events. So A and B is equal to probability of A, probability of B given A, or probability of B multiply probability of A given B. So this is the case of the conditional probability. If A and B are the independent, then this is the multiplicative rules.